Hello guys, in this video we are going to discuss the solution of the problem recursive sequence. So let us look at the problem statement. So a function f is defined as follows: fn is equals to 1 plus 2 into 3 plus 4 into 5 into 6 up to n terms. Given an integer n, determine the fn. Okay, and as the number can be very large, return the answer modulo 10 to the power 9 plus 7. So let us understand the problem with the help of an example. So let me switch to this. Okay, so let us say if n, which is given to us, is 5, then let us write down the function as well. So the function is equals to 1, then 2 into 3 plus here 4 into 5 into 6 and so on, right, till, and how many terms will be there in the function? So the number of terms, right, here number of terms is equals to n. Okay, so let's take some concrete example. So if n is equals to 5, then f of 5 is equals to what? So first we understand that there will be 5 terms. So one first term, then plus second term, then third term, then our fourth term, and then the fifth term. And the first term is start from what? So this will be just 1, and the next element of this. So 1 is there, and then 2, and how many numbers will be here? Well, there will be 2 numbers here, 2 into 3. Then the next term will be starting from 4, and how many terms would be here in this term? Well, 3 terms. Since this is third term, so 4 into 5 into 6. Similarly here it will start from 7, and the number of terms is 4 here. So let me write down the, so this is my first term, this is my second, this is my third, this is my fourth, and this is my fifth term. So here it simply means the number of terms over here will be 1, the number of terms over here will be 2, so this 2. Third simply means here there will be 3 terms. Fourth simply means here it will be 4 terms. So starting from 7, 8, 9 and 10, and here it is fifth, so there will be 5 terms over here starting from 11. So 11, 12, 13, 14, 15, yeah, these are the 5 terms. So if we add all these things and do a modulo 5 operation, we will get the number 3655527, and this is what we need to return. So that's about the problem statement, folks. Now let us look at the solution for this. So let us code it. So we want to print our sequence, or we want to return the resultant of this sequence, and n is given to us. So what we are going to do is we will have a variable which is answer. That is something which we are going to return, and initial value is 0. Second, we will have some mod of modulus number, and this is equals to 10 to the power 9 plus 7. So this is what we will keep with us to perform modulo operation. Then we will start with a variable called start, and start is equals to 1. This one simply is because we start from this term, right? So this is what I am storing it in a variable start. Okay, now let us see how we will be able to code it. So we need 2 loops over here, and the first loop, which is the outer loop, will be how many terms are there in the function. So let me explain this. So here I equals to I in range n. So for instance, in this example, if you see, for 5 there should be 5 terms. So this is first term, this is second, this is third and fourth and fifth. So this is what the first loop, which is for loop, which does. How many terms would be there? Okay, now once we are in the inner loop, or once we are inside the outer loop, we need to start from start, and we need to see when do we stop. Okay, So here we will have something called stop or end when is my outer or the inner loop will start, and that will be equals to start plus I, right? So I hold the number of terms which will be there in the ith term. Okay, then the sixth will be, and then we will have a multiplier variable which is equals to 1, and the seventh will be equals to while start is less than or equals to end. Okay, we will run over an example in order to explain this, but let's just go through the code once. In the eighth term, we will perform the individual multiplication. So this is equals to multiplier into start, okay, and the modulo operation mod, okay. And once we have done that, then we are going to the next element, which is equals to start plus equals to 1. And 10th, what we are going to do is answer, we are going to append it is equals to answer plus multiplier term, the term which we have just computed, or the ith term value, modulo mod. And towards the end, we are going to return answer. So that's the algorithm for this. Now let us run over an example in order to understand this example or understand this algorithm. So we wanted to compute f5, n which is given here is equals to 5, right? So let us see how we are going to do. So here I is equals to 0. So I'm just starting with the first loop, which is this. So I is equals to 0, and we have all these variable defined with us, which answer equals to 0 and start equals to 1. So let us look that. So here start is equals to 1 and answer is equals to 0. After that, we wanted to define end, and end is equals to what? Start plus I. So in this particular case, start is 1 and I is equals to 0. So we want to start from 1 and we go all the way till 1, right? That is what we want to do in the first term, isn't it? We start from 1 and we want to go all the way till 1. And then the multiplier will be there. The multiplier is 1, the initial value, and the inner loop will result into mul is equals to just 1, because it will run only for one iteration. After that, towards the end of this while loop, the start will be increased by 1. So now the start will be equals to 2, okay, and our answer will be equals to 1, which is answer plus mul. So answer is equals to 1. In the when I is equals to 1, so when I will go to 1, so here remember the start will be 2 and answer contains 1. Again, let's find out the end. So end is equals to start plus I, so 2 plus 1, which is equals to 3. So we want to start from 2 and go all the way till 3, and we want to multiply all the terms. So initial value of mul will be 1, and within the while loop we are multiplying all the values from this. So this will be equals to this, right? And modulo mod operation. So here we don't need it as such. And now towards the end of it, the value for the start will be 4, right? And here the answer will be updated, and the answer will become 1 plus 2 into 3. Okay, now when I is equals to 2, the start will be equals to 4 and answer will be equals to 1 plus 2 into 3. Alright, now let's move forward. Now the end will be is equals to start plus I. So start is 4 plus I equals to 2, which is equals to 6. And then we will compute our multiplier. So we want to go all the way from start, which is 4 to 6. So this will be equals to 4 into 5 into 6. This will be the result of internal while loop. And now the start will be updated by 1. So start becomes equals to 7. Hence the answer will have like 1 plus 2 into 3 plus 4 into 5 into 6. When I is equals to 3, so we are starting from 7 and answer is this. So again the end is equals to 7 plus 3, which is equals to 10. So the multiplier will be how much? Well, the multiplier will be from start to all the way till end, 7, 8, 9 and 10. So our answer will contain 1 plus 2 into 3 plus 4 into 5 into 6 plus 7 into 8 into 9 into 10. And the final term, when I is equals to 4, the start is equals to how much? The start will be equals to 11, right? Here we have, so start will be equals to 11 and the multiplier term will be how much? Well, the multiplier will be equals to, so before multiplier let's compute the end. End is equals to 11 plus I, so this will be equals to 15. This is 11, 12, 13, 14 and 15. So the answer will be how much? The answer will be equals to 1 plus 2 into 3 plus 4, 5, 6, 7, 8, 9 and 10. And the last one, which is equals to 11, 12, 13, 14 and 15. And remember, at every stage we are doing the modulo operation. So that's how, and towards the end we will be going to return this. So that's the explanation, folks. Now let's go back to our coding section and see how we will be able to code it. So the code looks something like this. So answer equals to 0 and the mod variable with us, and we're starting from 1. I ranges from 1 to 5, let us say, and is equals to start plus y and the multiplier, and this is the multiplier term. Here please note, here we are performing modulo operation, and once we are doing this, here also we are performing modulo operation, and towards the end we return answer. So now let's go ahead and submit our solution. So our solution got accepted. So that's from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I will try to address them. Thank you.